Hello grade 6, this is your video on the second part of your report, which is strands III and IV, the final part of your criteria B. So this is the final bit of your planning. After this you can go out and get your experimental results. So it's separated into two bits. We've got variables and we've got method. Okay. Variables, these are the things that if you change them, it's going to change something else. It's going to have an effect on something else. There's three types of variables. There's the independent variable. That's the thing you're going to change. There is the dependent variable. That's the thing you're going to measure and see what impact it has. And then there is the control variables. So in our work, we need to list all of these things. So we need to list our independent variable, how it's changed, and what range we're going to do. So the independent variable in our experiment is going to be the size of the parachute. Okay? Remember that very first introduction video. How did I say we would change the size of the parachute? It's a bin bag. We're basically going to cut it and then we're going to measure the edges and calculate the area. So I want you to describe that in as much detail as you can. Tell me how you'll calculate the area. I want to see a bit of a formula there, like, you know, the length versus the width to find the area. And then we're going to talk about the range. We're actually just going to have large, medium, and small. And from my calculations, let me grab a calculator. I think the large one, I measured it the other day, is about that by about that. Which means it's about 0.5 meters squared. Remember the units, they're important. Which means the small is probably going to be about 0.4 meters squared. Medium, and then the small is going to be about 0.3 meters squared. Yeah. Then we have to talk about our dependent variables, which is the thing we're going to measure. So we're measuring the time to fall 3 meters. How will it be measured? So you need to describe in here, you need to describe how you'll measure the time to fall. So you need to talk about the idea that you will have 2 people or 3 people. One person will be up at the top of the landing, which you've measured to be 3 meters high, and they're going to do a countdown and then drop it. And the person at the bottom is going to be with a stop clock, probably on your phone. You'll start the timer when they say drop, and then you'll stop the timer when the parachute lands. Which part of the parachute is going to land first? And will that be when you stop it, or will you stop it when the whole parachute has come down? You decide, and you describe that kind of detail in there. Any limitations? So what do you think there's any reasons why this might go wrong? What if it's windy outside? Do you think that will have an impact on it? Do you think a stop clock on your phone is good enough or not? It might be that you decide it's good enough, but what might go wrong in this experiment? What could go wrong with the timing of it? Then the last thing you're going to do is you're going to do your control variables. You try and come up with 5 if you can. 5 things that you need to keep constant, and then you talk about what effect that will have and how you're going to control it. So, for example, the mass of the hanging, it's called a bob, the little thing that you hang down on it, that would have an impact, wouldn't it? Because if that was heavier bobs would fall faster as they have more weight. Yeah? How are you going to control it? You're going to use the same bob for all experiments. Yeah? And then, so that's the first one. I've given you one. Can you come up with 3 other things that if you didn't control them, you would get different things? Maybe the length of the string would affect it, the wind that's going on, the height that you drop it from. All those things will have an impact. That is all strand 3. Yeah? This bit. The last bit is strand 4, where we do a method, and you see that you have to design a logical, complete, and safe method. So safe is very easy. You do a safety thing. So you say, what things could go wrong, and how will you control it? So things like people could slip. How are you going to stop people slipping? What rules are you going to have in place to try and reduce them slipping? Also, things like you're dropping something and it could land on someone's head. So how are you going to control that? How are you going to make that safe? Probably just going to have someone timing underneath it who keeps everyone away. Things to make it safe, basically. A diagram, probably you really want to be drawing it yourself, about how you're going to stand at the top. You're going to hold a parachute and you're going to drop it, and then someone else is standing downstairs with a stop clock, and they're going to time it to fall from here to here. That's your diagram that goes into that section, just so that people know what you're talking about. And then your method is like a recipe to follow to get the results. It needs to be as detailed as possible. Think very carefully about every single step you're going to do. Imagine it like a robot. If you don't say do that, if you don't say let go, it won't let go. If you don't say 3, 2, 1, drop, it won't say 3, 2, 1, drop, so the person timing won't know. Think about it as like a robot. How would you make it as detailed as possible? Because a safe, so look at this, safety is here. Yeah? And then the difference between this 1, 2 up to the 7, 8 is basically about how detailed your method is. Is it a simple method, or is it a logical and complete method with every step in place? It also says that you need to talk about the materials you'll use. For some reason that's disappeared off my copy. You need a materials list as well. It's disappeared off my OneNote for some reason. I'll try to add it in for when I send it to you. I hope that makes sense. Yeah.